Hey everyone, it's Carl, and this is week 3, problem number 5, kind of continuing on for what we've been discussing. You're a new manager of a small convenience store, and you're wanting to understand your customers' shopping patterns. So you have this 20 randomly selected purchases just from yesterday's records, okay? And so, kind of continuing on for what we've done before, in terms of creating the frequencies and those kinds of things from previous problems, I want to show you mean standard deviation. Mean is just another name for average. So in Excel, you can just do your average function right here. Just kind of refreshing you guys as you go along. And you just kind of close the brackets. And so then you get your average, which is 41.93. In this case, we're dealing with dollars and cents. And so what you want to do is kind of cut that off into the hundredth place or the second spot. So this would really be $41.93. Except for gas prices, if you noticed. In terms of standard deviation, same thing. Standardize. Standard deviation is right here. But actually, you want to do sample in this case. But in Excel, in older Excel versions, we can do that as well. It's just really this one. And that's really what we've done. Newer Excel versions, you want to go for that. But we'll go ahead and stick with the older version just for now. But this one, the S, and this are the same. This one, as you can imagine, is a population. So you're dealing with much larger groups. But for our purposes, we either want that one, the STDEV, or the STDEV.S. Either way will get you the same. So we'll go ahead and do this. This is our standard deviation. We'll do our group again. 22.97, or as if we could round, and that's another thing we can show you right here, is rounding. You right click, say you want to make sure that you get these into dollars. So what that'll do is get us into, if you right click, it should, we want to format these. Or what you could do too, in addition to this, is your layouts, where you can go home. You can go to the home function, and actually create it yourself right here. So right here in this number column, and this is universal across most Excel versions, where you'll have a category that you can actually do the formatting yourself. So $22.98 is your standard deviation. $41.93 is your mean or average. So, good thing to know just kind of going into this problem. So first question here is to standardize the minimum and maximum purchases. And so you want to find the z-score for your minimum and maximum. So what we're going to say is, remember this, z is your y minus your y bar, or mean, divided by the standard deviation. So you want to figure out your minimum purchase. So in our minimum purchase, just from eyeballing, is $2.56. So we're going to take this, and we're going to do the 256 minus your mean, and then divided by the standard deviation. This will get us the z-score for the minimum purchase. Close the brackets. And that's our z-score. Now, similarly to our maximum purchase. Now, our maximum purchase, it's easy with 20 records. It's the $77.07, or 70 cents rather. So it's a little bit easier to do in this context. But when you have larger populations, we'll show you how we can do that. So it's this minus your mean, or y bar, divided by your standard deviation. And so that gets us that. So, and which is the more extreme z-score? And what we're talking about is absolute value, ABS. When you take the absolute value, which is greater? That's really what it's asking. And so you can tell here absolute value, which is greater, and to make sure you can get this absolute value. What is absolute value? It just means what's the number, regardless of if it's positive or negative. What's the number? And this gets you the absolute value, the ABS function in Excel. So which one is greater? Based on their absolute value, it is the z-score for the minimum purchase. So just kind of answering that question for you. Last question: How large a purchase? How large is a purchase with a z-score of 3.5? So remember, this kind of takes a little bit of reverse engineering in a sense. So we know 3.5. So we're already given z in this equation. Now we got to figure out, so what is the y? We know these values. We know the mean, or y bar. We know the standard deviation. So a quick way, if you think about it, turns into an equation, is the z is 3.5, and we know this. So really what we're wanting to do is we're wanting to take this standard deviation and multiply it by the z. What that does is this cancels this out. It cancels your denominator when you multiply. And then, so right now you have the standard deviation times z. And then after that, you have, really your equation rather, is standard deviation times z equals y minus the mean. So, to cancel that out, now you'll have to do the opposite and add mean. So you do plus mean here, it cancels, but you're adding a plus mean on both sides of this equal sign. It's kind of just the fundamentals. So you have the standard deviation times the z plus the mean equals your y. So we'll write that out real quick. So it's your, and we'll do it in brackets to kind of make sure we track it. The standard deviation times the z that we're given, which is 3.5. That's a really big z value. And then plus our mean, or y bar. And that'll get us our value. So $122, which makes sense in this case, because if you think about, our maximum purchase, the y bar was 77. And that was a z-score of 1.5. So you think about 3.5, you think about just how much higher that must be going in the direction, because if a minimum gets to negative, so it gives you a good sense of like just how large this number could be. So that's $122.36 is how large a purchase would have to be to have a z-score of 3.5. So I hope this brings some clarity, and just let us know if you have any questions along the way. Thanks so much.